Today we're going to be talking about section 2.5, equations with variables on both sides. That's on page 24 of your notes, so make sure you turn to that page now. At the top, there's a table. We're going to fill that table in a little bit later. Today we're just going to do some of the most basic equations that have variables on both sides. So example 1a is what we're going to start with. I'm going to show two different methods for solving equations with variables on both sides. The first one is a more traditional method, closer to what you've been doing with multi-step equations. The second method still uses a lot of the same principles, but it helps us organize our information a little bit better. Some people prefer one method over the other. I don't really have a preference as to which one you choose. I am going to ask for the first problem, example 1a, that you write down both methods on there. And then for example 1b, you can choose which method you would like to use. Just a reminder, when we're solving equations, we always look at the left side and the right side, and we work our way down the order of operations to simplify both sides. So that means when I'm looking at this left side, I notice that there are no parentheses that need to be taken care of. There's no exponents. There's nothing that can be combined using multiplication, division, addition, or subtraction. This is as simplified as it can be. The same is true for the right side of the equations. No matter which method you choose, that's always your first step. Work your way down your order of operations to make sure that each side is simplified. Second, we're going to work our way up to solve. But when we do that, our first step needs to be, with this more traditional approach, is to move the variables to one side of the equation. For ease and simplicity, I am going to choose to always move the variable to the left side of the equation. That means that this 3x needs to move to this side of the equation. I'm going to do that by subtracting 3x because it is a positive 3x. Now, we can only do that with like terms, so it has to be subtracted only from the 6x. It doesn't touch the 13. So I have 13 left on the left side, and negative 6 minus 3 gives me negative 9x. And it equals negative 14. It should now look identical to our two-step equations that we solved so much over the last couple of weeks. So I'm going to subtract 13 from both sides. And it leaves me with negative 9x equals negative 27. If I'm still trying to get my x to be alone, I've done the addition and subtraction. I'm working my way up the order of operations to multiplication and division. So I'm going to divide by negative 9. So that x is equal to a positive 3. So if I were to check this problem to make sure that I had done it right, I have now two sides that I have to plug that 3 in to make sure it works. I have to do 13 minus 6 times 3 and get a number. And I'm going to check that when I plug 3 in on this side, 3 times 3 minus 14, check that you get the same number. And as long as you get the same number on both sides, you know you've done this problem correctly. This is the same problem, number 1a. We're just going to use the other method to solve it. So just like the other problem, my first step is to look at the left side. Let me make sure that it's simplified, and it is. Now let's look at the right side, make sure that it's simplified, which it is. My next step, once each side is simplified, is to draw a variable box on the left side and a constant box on the right side. The top two boxes represent the two terms that have variables, because I see that there are two terms that have variables in there. On the right side, I have two boxes on the top because there are two boxes or two terms that have no variable. Now, this negative 6x is going to go into the variable box. And because it's staying on the same side that it started with, it's going to have the same sign. And I want the 3x to join it. But it has to move to the opposite side of the equation, so it needs to be the opposite sign, negative 3x. Now for my constant box. The negative 14 is on the same side, but the 13 needs to move to the opposite side, so it will be the opposite sign. Now we just have to combine our like terms. Negative 6x, negative 3, that gives me negative 9x. Negative 14 minus 13, that gives me negative 27. So I have negative 9x equals negative 27. I want to get rid of the negative 9 by dividing both sides by negative 9 so that x is equal to positive 3. So you have two methods of solving the same equation. Again, I don't have a preference as to which method you use. You just need to pick one and practice that method. So I'm going to do 1b now, and I'm going to use both methods. So the traditional method first. Remember, I'm checking to make sure that it's simplified on the left. And I'm checking to make sure that it is simplified on the right. Since both sides of the equation have been simplified, I can now move my variables to the left side. That means that I'm trying to get rid of this 4x by subtracting 4x from both sides. So I have 7 minus 12x. Negative 8 minus 4 is negative 12. And negative 17 is left on the right. Now we're working it just like a two-step equation. I have to subtract 7 because it's a positive 7, leaving me with negative 12x equals negative 24. Now we're going to divide both sides by negative 12. So negative 24 divided by negative 12 gives me positive 2. Let's take a look at the other side, or the other way to solve this. Remember, you only have to write down one way, whichever way you think is going to be easier for you to practice. With both ways, I check to make sure that both sides of the equation have been simplified as far as they can. And I know I'm going to move my variables to the left side. So here's my variable box. I see two terms that have variables, so I need two spots to put them in on the top. My constant box is going to be on the other side. I see two terms that have constants, or terms without variables, so I need two spots to put them in. Negative 8x is on the same side, so it goes with its same sign. And the 7 has got to be moved to the other side, the opposite side, so it becomes a opposite sign, so negative 7. Now the other one. The x's are moving to the left side, so it means to move to the opposite side, so it becomes the opposite sign. And negative 17 is staying on that side, so it receives the same sign. I have negative 8x minus 4x is negative 12x. Negative 7 minus 17, negative 24. Now I need to divide both sides by negative 12. So x is equal to positive 2. Again, either way you go about this, you should still get the same answer. You're now going to do classwork problems number 1 through 10. I need to see work for either the traditional method, the first method we used, or for the box method, which is the second method.